Hi, this is Randal Schwartz, host of FLOSS Weekly. This week, Dan Lynch joins me to talk about VoltDB, a database that scales even though it still uses SQL. You're going to want to see this, so stay tuned.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for FLOSS Weekly is provided by Cachefly at CACHEFLY.com.
This is FLOSS Weekly with Randal Schwartz and Dan Lynch. Episode 149 for January 19th, 2011. VoltDB. This episode of FLOSS Weekly is brought to you by mailroute.info. Visit mailroute.info to sign up. As a Twit listener, you'll receive a 10% discount for the life of your account. Mailroute.info, filtering viruses and spam away from your mail servers. It's time for FLOSS Weekly, the show about free, libre, open source software. I am your host, Randal Schwartz, bringing you weekly or as often as I can all sorts of interesting big projects, small projects, commercial projects, little projects, desktop projects, operating systems, communities. Did I cover it all? I must have covered it all. What I didn't cover yet, though, is my co-host for this week, none other than Dan Lynch. Welcome back, Dan.
Hi, great to be here.
Got you a little off guard, huh?
No. Yeah, it's great to be back and in the co-host seat again, in the co-pilot seat again this time. So Absolutely. I get to watch.
Absolutely, I really appreciate you taking over the host slot when I was out at sea last couple times. Actually, last time I think it is. You've got a few more of those coming up, but just really wanted to thank you for doing that job because I felt that it was in very great hands, and you and Aaron had some really nice interactions. So I appreciate that as well. So good deal, very good deal. And so, and this, before I get too much further in this opening, I want to apologize for those of you that listened last week. I named the guests in the title of the show, and then I just brought them on, and I never talked about what the project was. And good thing I said as I was bringing them on, I did a really horrible job in the intro, because in fact I did a really horrible job in the intro. So this time I'm not going to do that. This time I'm actually going to introduce the guest. This is very important. We have on this week, we have John. Now I'm really messing it up. John Hogg, who is representing VoltDB. Now, VoltDB is a database scaling solution, like we've had so many of on this show over the last couple of years, because databases scaling is very important now. Unlike most of these other ones, where you kind of had to give up the whole SQL model to make it go better, these guys have figured out a way to actually keep the SQL model as part of the solution, but find other ways to make things go faster. So I'm really looking forward to this. Sounds interesting, huh?
Yeah, it sounds fascinating. As you say, the whole NoSQL movement is really big at the moment with CouchDB and all these other things. And it seems that there's a third way. There's now a third way, which is what VoltDB are doing. So it's going to be really interesting to find out exactly how that works.
Very good. Well, we'll get them on in a moment, but before we do that, we actually have a sponsor for this week. I really like that when that happens. So our sponsor this week is MailRoute, mailroute.info. Businesses of every size use MailRoute. 1 user, 50,000 users, doesn't matter. MailRoute's going to protect you from spam and viruses. They simplify your life and make your email usable again. MailRoute is a secure hosted service that filters virus and spam for companies of any size. Whether you're a single user or a company with tens of thousands of employees, MailRoute can eliminate viruses and spam, reduce the load on your email server, lower your costs, and make your email usable again. Typical MailRoute customers see a 95% reduction in their inbound email volumes with virtually no false positives. That's really important. So Leo Laporte, in fact, loves MailRoute. He's been using the service for his domains for more than 6 years, and MailRoute's been his top choice for spam and virus filtering all along. And I've heard Leo talk a lot about this, so I know it's really working for him. Tom Merritt started using MailRoute. I know that he can use email domains that he'd given up on being able to use as hopeless. And Tom Johnson, who founded and is the CEO of MailRoute now, started one of the very first companies in this market back in 1998 called FrontBridge, was acquired by Microsoft in 2005, and still offered as Microsoft Exchange hosted services. Tom wasn't done, though. He had too many good ideas, and he couldn't stand to see it go to waste, so he started MailRoute, his next-generation service for filtering email with a level of accuracy and a price that's unmatchable. And I know from running my own servers that filtering email, filtering spam, filtering viruses out is a difficult task, so what MailRoute.info is doing for you is really an important thing to get done. There's nothing nothing easier than mail filtering with MailRoute. There's no hardware or software to install. You just sign up with MailRoute, and then you change your MX records to your domain to start your mail flowing through them, and they bounce it back to you with everything filtered out that needs to be filtered out. Visit mailroute.info to sign up. As a Twit listener, you're going to receive a 10% discount for the life of your account. Small business accounts start at $2 per user per month for 10 users, and because of the demand for the Twit Army, MailRoute has added a new service for individual users as well, less than $30 per user per year for single users. Visit mailroute.info and sign up with the email filtering service that Tom and Leo use. Very, very cool stuff. So with all that said, now we have our sponsor information in the show. Dan, shall we bring our guests on?
Let's do it.
Hello, John.
Hi, Randall.
Hey, where are we speaking to you from?
Billerica, Massachusetts. I'm at VoltDB headquarters.
Very good. Right there at the headquarters, right with the information directly down the hallway. Wonderful, wonderful. Now, right. I had a kind of did a half job of describing what VoltDB is about in the opening, but I'd like you to describe sort of the 30-second, maybe 1-minute overview of what VoltDB is about, but I want to come at this from a slightly different perspective. Let's first talk about the problem space that VoltDB is trying to address. So what kind of problem would I have before I would look at VoltDB, and how does it solve it differently from other people?
Okay. Well, VoltDB is trying to solve a similar problem that a lot of people are really interested in now, which is kind of this big data or high volume data that is kind of overflowing a lot of systems that people have built for the last 20, 30 years. So this is kind of in the spirit of a lot of the NoSQL systems. They're looking at scalability. How do I get my app to handle what was a normal workload yesterday? This year, I've got 10 times the volume. The internet, machine sensors, just changes in lifestyle have driven the amount of data that we collect, process, store to new levels, essentially. And everyone is scrambling to figure out what's the way we're going to collect, process, and store this data. And the database, the data store layer, in some cases, is kind of the fundamental place where a lot of that happens. And VoltDB is one solution in that market that's eager to do this. We came at this from, I think, a very different angle than a lot of other systems come at this, but very much towards the same problem. So VoltDB is a SQL database. It's a relational data store, so it works just like MySQL or Oracle or SQL Server or Postgres if you're used to these relational data stores. But we make a kind of a different set of assumptions, a different set of trade-offs to build a system that can handle 100 times the amount of data, and someday 1,000 times or 1,000,000 times the amount of data that these systems can handle. And I should say, when I say the amount of data, I don't necessarily mean the volume of data, but more the transactional throughput of the data. How many things are happening within the time frame of a minute? How many things are happening within a second? And that's kind of where VoltDB was built to scale. So how is VoltDB different than all the NoSQL systems or the more scalable SQL systems out there? VoltDB is basically looked at this problem but said, we don't want to give up any of the ACID guarantees, the transactional guarantees that your legacy database systems give you. And that's the ACID stands for the transactions against VoltDB are atomic, they're consistent, they're isolated from each other, and they're durable. If you check out the Wikipedia page on ACID, it explains all of that. But VoltDB doesn't give any of that up, and yet still scales to tremendous amounts of throughput. So we're talking anything you measure with VoltDB, it's kind of in the millions per minute range at the very easy to achieve scalability of VoltDB. That said, that a lot of our users are not necessarily interested in millions per minute, but they're interested in, whatever MySQL can do plus X. Or whatever their existing solution can do plus X. And VoltDB gives them that, and then it gives them the headroom to grow. So that's kind of in a nutshell what VoltDB is.
Okay, so the problem space is a very common problem space that we have now, which is that you build a web app or an online transaction app of some kind, and you're a victim of your own success because you start putting it out there and you think, oh, I'm going to have maybe 10 visitors a minute or 100 visitors a minute, and then all of a sudden you get 10,000 visitors a minute or 100,000 visitors a minute, and we've all seen this over and over again in things like Twitter and Facebook and MySpace and stuff crashing from things being MySpace, that's dating myself there, but anyway, all these things crashing because things are developed out too quickly. And and I want to make sure I heard this correctly and re-echo it back. So VoltDB is not a NoSQL solution like maybe some of the ones we've had on the show before, like React and so on. It's actually a real SQL interface. So you interface with it using SQL calls, correct?
Well, I mean, that's an interesting question, I think, because NoSQL, a lot of people say, this doesn't actually mean, NoSQL. This means we're going to look at a different set of trade-offs. We're going to build a kind of a from the ground up reimagining of the problem. Mm-hmm. So in a lot of ways, Volt shares a lot of philosophical traits with these systems. Volt is kind of throws out a lot of the bathwater, hopefully keeping the baby. Mm-hmm. To get this faster performance. So in some ways, you could be fair to call VoltDB NoSQL. In other ways, it's very different. VoltDB is definitely a SQL database. It's a relational database. It's designed to give you those ACID guarantees that the old legacy relational databases give you. So it's kind of a mix of both worlds, a different set of trade-offs. And just to address one more thing that you just said, VoltDB is also certainly interested in kind of the web apps that you mentioned. I create a web app and I've got suddenly the amount of users I have is overwhelming the backend that I've built, or I'm anticipating that will happen. But there's another big revolution in data now, such that we want to handle these streams of data that have maybe not necessarily have a web-facing front end. So, for example, I want to have RFID tags on things all over everything in my warehouse or everything in my store, and I want to have a transaction that records every time something moves. Or I want to have a transaction that records every time something moves through some transactional process. So whereas it used to be enough just to know how many of widget A do I have in my warehouse, now what we want to know is where is every widget A in my warehouse and where has it been for the last 5 minutes. And this is kind of driving some of the growth in transactional volumes, apps like this. But also back-end systems like financial data, stock market ticks are another example of a tremendous volume of data that as machines start to take over from humans and actually making these stock orders and stock executions, that the tick data becomes much more voluminous, and we need better computers to handle the result of what the computers did.
So good. So let me clarify a couple things again. So again, to contrast yourself with the NoSQL solutions that are typically document stores, though, you're really talking about traditional rows and columns and foreign keys and stuff. So you have to decompose your data structures into something that would be SQL compatible, right?
Well, we do ask you that you make SQL tables so that you have a DDL file just like you would in your MySQL database. How much you normalize or denormalize that data is really up to you. Some people come at this and they like the fact that with VoltDB we handle all of the scalability and you can keep your data as normalized as you want. Or if you want to, you can denormalize your data and just store keys and values in VoltDB. And that's something we've done some benchmarking with. It's a really legitimate use for VoltDB, not necessarily using all of the features of VoltDB, but we can do that at extreme throughput with redundancy.
Okay, now in any situation though, there's always optimization for different things. So as you said, you're keeping the baby, but without throwing out without throwing out the bathwater. I'll get to see him right yet. This English thing is still hard for me. So what parts of the similarity to NoSQL solutions are you keeping? Let's examine that a little bit more.
Okay. Well, I mean, NoSQL is a really broad term, and there are a lot of different systems. So it's certainly possible to compare against specific systems. Comparing against the whole swath of the NoSQL landscape is dangerous, perhaps, because there's always some exception to some rule where, well, you forgot about this system that does this or this system that does that. But VoltDB, the difference is perhaps we built a system that allows you to keep transactions, which essentially a transaction you can aggregate a bunch of operations. So I can start with an example because that might be an easy way to explain it. One of our example applications is what we call Voter. And Voter is a simulation of an American Idol style voting on a set of contestants to a show. You know, possibly people are calling up and paying $1 to vote during a commercial break. And so one of the things that Voter does that's difficult to do in other systems is that Voter puts a limit of 10 phone calls per phone number. So you can call up 10 times to vote for whomever you'd like to vote for, but if you call that 11th time, VoltDB is going to tell you, sorry, you can't vote. And that's something that counting is a difficult check to do, because in systems that don't have the transactionality that VoltDB has, it's very difficult to know if you're the 10th or if someone else at some other part of the system is the 10th, if things are happening in parallel. Where VoltDB, you get effectively these logical locks on your data such that you know that if you read the number of votes for a particular phone number and it says 9, then you can safely vote and you're going to be the 10th item, and that no one else is going to be the 10th at the same time. So the next call to come in from that number will be automatically the 11th and can be immediately rejected.
So what you're optimized for then is parallel transactions, and many of those quickly in a short period of time.
Yes, that's true.
And what's the trade-off for that? Because everything, my friend Larry Wall likes to talk about complexity is like a waterbed. You push down to one spot and water comes up on the other side, because that's where the complexity has to show up if you make it simpler in one area. So what's the trade-off here? Why wouldn't I use VoltDB for everything then? Okay,
so the two big trade-offs in VoltDB, and one of them may or may not be, is that, first of all, we ask you to partition your data. So this means that given a particular workload, you need to decide what operations, how you can partition the operations. So for example, in the Voter app example I just gave, you could partition on phone numbers such that you'd put certain phone numbers on certain machines, or even on certain CPU cores of those machines, and that you'd put other phone numbers on other machines. So for the Voter application, that's trivial. You just partition on the phone number. But for some applications, it can be a little bit more involved. And then so there are those applications that don't partition at all. Anything that's very graph-centric, such as social networking, is difficult to partition onto a system like VoltDB. But on the other hand, there are a lot of applications that partition on customer, partition on user, partition on product, partition on stock symbol. And these applications partition very well. The other thing that VoltDB, the kind of trade-off, is that VoltDB's interface is a set of stored procedures that we ask you to tell us about in advance. So this is a limitation in the interface in terms of it affects the developer of applications. You basically give us a set of all the things that you're going to do to your data and how they're going to be tied together in terms of the transactions. You give us, say, these SQL statements and logic compromise one stored procedure, and here are the 100 stored procedures or the 5 stored procedures that I'm going to run. And VoltDB will compile this into an application and then let you run your application against it, sort of like a database API. So instead of saying, send over the network, select star from table, then insert into table, what you do is you'd say, I'd like stored procedure update, employee 5, and then you pass in parameters with perhaps a new salary, for example. So it's a different model of working with VoltDB than it is with working with some of the NoSQL systems that largely allow you to just kind of query them in a very ad hoc fashion. They don't ask you to know a whole lot up front. Now, that's not to say that we ask you to give us a fixed set of procedures. You can change this fixed set of procedures on the fly, but for any given point in time, we have one fixed set of procedures that you can run. So that allows us to optimize, and get you a tremendous throughput on that application.
And one thing I was curious about, John, is what kind of hardware would I need to run this on? What kind of platforms can I deploy VoltDB on?
So we do a lot of our testing on very commodity 2-socket Intel hardware, kind of in that several $1,000s a node, but maybe less. But we also do a lot of our testing on much slower machines, single-socket kind of machines. We do a lot of testing on Amazon's cloud. In terms of platforms, we support Linux, basically recent kernels, 2.6, 18+. We support specifically CentOS and Ubuntu, but it runs on pretty much anything. We also support Mac OS X as a development platform. We see a lot of people who want to use their Mac laptop to build the Volt app, and then they want to deploy on either Amazon's cloud, somebody else's cloud, or in their back room with a bunch of Linux servers. But VoltDB does not require tremendous hardware in order to run. It's not a system built for 8-way servers or specialized appliances. It's a system built for the machine you probably have lying around, the servers you probably have lying around. That's not to say it won't run better on newer machines, but it runs on a lot of things. I should also say that we are a 64-bit only product, so we run on 64-bit systems, which nowadays is more and more common.
So you mentioned CentOS and Ubuntu. Do you have packages in the Ubuntu repositories and the CentOS repositories, or do I go somewhere else to get the package and then install it?
So you come to VoltDB to get the package and install it. That may change someday, but right now we're probably updating faster than these package repositories will update. But come to VoltDB, download our tarball from voltdb.com, and it unpacks into a directory, and you can run Volt from any directory. The installation of VoltDB is not a really complicated thing. It just unpacks and you can go.
So one thing I was curious about is how easy is it for me? Obviously, scalability is a big thing for you. So how easy is it for me to say, I'm struggling here, I need a few extra servers, I'm just going to throw these in? Is it very easy to do that and quick?
So it's not what the current process for adding new servers to VoltDB is. You have to quiesce your Volt system, you stop it, and then you add the servers and you restart it. And so currently there's a service window for adding more machines, but you don't have to do anything to add more machines. So you become unavailable for, depending on the size of your data, possibly minutes. For tremendous amounts of data, maybe longer, but usually a very short window. And then you'll have your system up. It'll have more machines. We'll have repartitioned everything for you, and you'll be running quite a bit faster, or quite a bit more redundant if that's your aim for why you're adding more machines. And I should say this is an engineering challenge, less than an actual fundamental limitation of the product. So in future versions, this will be something you can do on the fly.
Oh, excellent. So obviously VoltDB is running in memory. So I'm curious that kind of makes me worry that what happens if there's a hardware failure, or my data center gets blown up or something. How do you deal with fault tolerance and stuff like that?
Okay, well, first of all, VoltDB allows you to specify the redundancy level you'd like your machines. So where a lot of traditional systems will keep a database log on disk, what VoltDB does is it makes sure that your data lives in as many places as you specify. So you can tell us you want things in 2 places or 3 places, and then what that allows is that individual machine failures become a nuisance rather than something that actually stops your application. So if you say, I'd like 3 copies of everything, that means I could pick any 2 machines in your cluster, kill them, and it's not likely that you would notice a tremendous impact to your running application. VoltDB behind the scenes makes sure that the things that we said are committed stay committed. The transactions that are in progress get routed to the machines that are still up, and everything continues smoothly, maintaining all the guarantees we maintain. The only thing that would at that point is that you can run, if you're running in a reduced redundancy mode, you're more vulnerable, and you'll have to add those machines back in once they're working again. That's the first prong of what VoltDB does. The second thing VoltDB does is we support rolling snapshots of your data to a disk, such that generally on a minutes basis, you'll have a transactionally isolated snapshot of what's in your VoltDB state on disk. And you can keep several of those, as much room as you have a disk. That's a policy that's configurable.
Oh, excellent. So even in the event of complete power failure, you'll still have your rolling snapshots. That's excellent. So I was, sorry, go on.
Oh, I should say that in the event of a complete power failure where your battery backup system gives you no notice, you'll have a rolling snapshot. You may lose the very tip of the transactions. So if your snapshot is a minute old, you may lose a minute worth of data. That's something that we're going to keep improving that story, but it essentially it's a very rare event to lose data with no notice in a modern data center.
Yeah, of course. I was just Just playing devil's advocate a bit there.
No,
I was
fine.
curious. I was reading that that you use a shared nothing architecture. Could you explain that a little bit, just for benefit of listeners?
Sure. Well, like I said, we allow you to basically, if you specify a redundancy level greater than 1, unplug any VoltDB node. So all our VoltDB nodes are identical. They all run the same software. You can send VoltDB transactional requests to any node, and they'll get routed to the right place. So it's very easy to either, in software, distribute your load round robin between machines, or to put a load balancer in front of VoltDB and treat them all as one big kind of organic cluster. So that answers that, I guess.
Okay, thanks very much. So what kind of applications really fit the the sweet spot for VoltDB, for really making use of all that speed and power that you've got?
Well, I think that VoltDB enables certainly things where there's information out there that's so big that I couldn't process it without something like VoltDB. So that's one market. We see some traction there in financial markets, like I said, where the number of stock ticks is so large that that the systems to process it need to continue to get better. And VoltDB can process millions of stock ticks a second if that's something that you're interested in. And then the other area is data where you need to scale, but the idea of what you don't want to do is you don't want to spend a fortune. You can always, it seems like for many of these applications, you can call up IBM, you can call up Oracle, you used to be able to call up Sun, and they'll, for millions and millions of dollars, send a team of consultants out there and make your app work. And that's what a lot of these expensive systems like the banking systems have done over the years. But now that we're in this kind of Web 2.0 startup world, a lot of people want this level of performance, but they want it on a shoestring budget. And VoltDB is great for this. It's really easy to try. It's free to try. You can deploy. We have support contracts that you can that are just a tiny fraction of what other guys charge, and so that opens up things like the kind of traditional apps. We look at flash gaming. Storing the state for these games where you're monetizing the user in terms of pennies. Your transactions need to cost fractions of pennies. Web advertising. It's really interesting to be transactional in web advertising. You want to charge your client when you show their ad. You want to make sure that the client has a balance in their account with you before you show the ad, so that kind of thing. All these things, though, the transactions need to cost a fraction of what the actual event costs. So you don't want to charge your user 10 cents to show an ad, but then charge 9 cents for your transaction. And VoltDB allows you to do, like as I said, millions of transactions for tiny amounts of money. You put together a cluster of nodes on Amazon's cloud, and really you can get scalability that's unheard of at the cost. So I talked about advertising, flash games, flash state, online security. So people are using VoltDB to monitor event messages from their security systems, sort of like a giant version of Snort. Machine-generated logs, so sensor data, RFID tags. These are an interesting thing to process through Volt, because Volt allows you to collect this data and within less than a second have all kinds of real-time dashboarding information about it. And then this information can be moved as it grows older into a system that's probably better suited towards the long-term processing, like an analytics database or a Hadoop cluster.
Cool. That sounds like a lot of really interesting applications this works for. I'm curious, the programmer in me, but obviously not the person who can elocute these things. The programmer in me is curious, what's the interface that I'm dealing with? You talked about stored procedures before, and I heard Java mentioned as well. What am I interacting with when I'm trying to get VoltDB to do what I want it to do?
Okay. Well, so VoltDB has two components to your application. It's got this set of stored procedures that runs on your inside your database process. So in the case of the voter example, again, there's a stored procedure called vote. And the stored procedure called vote accepts as a parameter the phone number of the person voting as well as the person they'd like to vote for. And what this then does is it runs a Java method that you provide to VoltDB ahead of time that that can run SQL statements embedded in it. So the SQL statement to look up that phone number to see how many times they voted, SQL statements to record a vote, or SQL statements then to check what the response should be to send back to you, the client. Could be either this person has voted too many times, this person is an invalid phone number, or this person voted successfully for the 7th time, essentially. So that's one side of the application, and currently those stored procedures are written in Java, although people have written stored procedures in other JVM-based languages. I think we've seen Scala stored procedures. On the client side, essentially what you're asking for is call a stored procedure. So I'd like a number 5 with fries. Here are my parameters. And that can happen. Currently, there's a Java client that's very mature for VoltDB, of course, because it works very in concert with the Java stored procedures. But we also have clients in C++, clients in Python. We have community-contributed community-contributed clients in Erlang and in Ruby. And we're working on more all the time. We have a PHP client also. So you can, from any of those languages, essentially call the name of a stored procedure and it will return a result set to you. It's a very simple interface.
So I would have like the traditional 2 layers of programmers there, where I'd have the sort of the database programmers that would probably create all those stored procedures. Then I might have the application programmers who then interface with those.
You could set it up that way so that you could, or you could do it entirely one set of programmers. One of the things we're really pushing on in VoltDB is to reduce the number of knobs and tunability of VoltDB that you need to understand to get the performance you want. There's a little bit of, as I said, thinking up front about how I can partition my application, but largely once the partitioning of the application is figured out, VoltDB is very easy to get tremendous performance. It's not some kind of enigma with lots of knobs and settings and what should I set this buffer size to and what should I set the number of things before I commit blah to, if you look through any of the configuration systems for a lot of traditional databases. So we really like to make either the burden on the DBA easier or remove kind of the DBA or change the DBA role in terms of VoltDB.
Great. And how long ago did VoltDB start, and what was the impetus for that, and how far along is it? Is it usable now? Is it production ready? Where are we at on with the project?
Oh, okay. So VoltDB started as the HStore project in 2007. It was a collaboration between MIT, Brown, and Yale professor groups with Mike Stonebreaker involved, Dan Abadi, and some others. And what they basically did is let's take a look at the database and let's change our assumptions for OLTP specifically, let's take our assumptions for OLTP and look and see if we can build a database for the 21st century based on these assumptions. And so they built a system, a prototype system that ran kind of a TPCC style workload 80 times faster than benchmarking against a legacy database, and said, this is a valid product. So at that point, I was brought on to start the team that became VoltDB, and we took the HStore prototype and together with a whole bunch of students actually at MIT, Brown, and Yale developed the kind of slightly more commercialized version of VoltDB that actually ran SQL, that ran stored procedures, that was looking more like a prototype system. And at that point, sometime in kind of mid-2008, end of 2008, the products diverged so that VoltDB was founded and became the commercial version of this technology, and the HStore research project kind of split off to answer more fundamental research questions about the technology that we're really interested in the answers to. But VoltDB released a 1.0 in May of 2010. And since then, we've had several releases, a 1.1, a 1.2, and recently a big patch to 1.2. So it's a production-ready system. We have customers using it. It's a really exciting database. It's just getting better all the time.
Can you tell us a little bit about your open source licensing model and how all that kind of stuff ties in with what you're doing?
So VoltDB, the server itself is 100% GPL3 licensed. So you can download VoltDB, you can fork it, you can redistribute it, you can do kind of whatever you want with our source code. And that's been very successful for us. We got people really excited about Volt as an open solution to scalability, because there are a whole lot of closed solutions. In terms of the transactional space, there are a lot of closed solutions. There's a lot of open NoSQL solutions. But VoltDB also has a management tool that we have a closed source management tool that kind of allows you to manage some of the VoltDB servers. It's certainly not necessary. People use VoltDB without it, but it's a nice tool that comes with support contracts for VoltDB. More information about that can be found on our website, but I'm mostly focused on the server product, which is the 100% open source GPL3.
Excellent. So at the risk of asking the horrible, dirty question, how does the company make money out of it then? It's a support contract model, that kind of thing?
Yeah, well, I think that having that support is an exciting thing. We do sell the enterprise license, enterprise manager that VoltDB makes. It's a really nice way to deploy and monitor your VoltDB applications. We're adding a whole lot of features to that in our next release, which is going to be really exciting. But people, we own the code 100%. It's all copyright VoltDB, so we can never unrelease anything that we've released, which makes me comfortable because I'm a big open source aficionado. But VoltDB could add proprietary features in the future that would be closed source. I don't expect a lot of that, but it's flexibility that we have.
Excellent. So obviously, being an open source project, you'll have a community of users and developers and so on. So what's the kind of the breakdown of people working? Is there anybody working on VoltDB, submitting patches and so on outside the company?
Well, there was a lot of contributions initially from like, as I said, the students who are some top grad students at Brown and at MIT and at Yale. Now they're more focused on some of the more interesting research questions like automatic partitioning or faster multi-partition transactions. But VoltDB, the breakdown is we've had people who used it who've contributed certainly peripheral things. We've gotten client libraries, as I said, in Erlang and in Ruby that use VoltDB. We've gotten some people who've discovered bugs in the code, which has been nice. But I'd say the core product is largely VoltDB committers at this point. But we expect a whole lot of additions. One of our customers has been interested in submitting, I think, packaging improvements, integration with SNMP. So there's features coming that are from customers that we're excited about at VoltDB. And as the product grows, we welcome contributions. We welcome people getting involved. We have an IRC channel, and you can find out about all that information on our website.
Excellent. Is there any kind of Git repository or something that you could sign up to and check out the code and then maybe work on it yourself and submit patches and so on?
If you go to voltdb.com, there's a community button at the top, and on the community page, there's a Get Involved section. It describes where our public SVN repository is. We've got some people who've, I think, cloned that into GitHub, but I'm not sure exactly if that's public, but you could certainly do that. And also, our bug tracking database is open for anybody to see. So we have forums. It's easy to get involved in VoltDB if you want to be part of this community.
Excellent. And I was curious, do you have any idea how many deployments there are of VoltDB? Because obviously there's some giants in the database area like Oracle that we all know about. But I'm curious, how's it going with deployments and so on? Is it a growing thing?
Well, it's certainly a growing thing because it's a very early product. So it's not a it's definitely a lot of room for growth in this market, but I don't know how much I can speak to actual deployments, partly because I don't know all the deployments. Once in a while we get somebody who calls us up and says, we've been using VoltDB and we need some help, which is exciting, and it's always fun to help them from a community involvement standpoint. But I think that keep checking in on our website. We'll have some announcements about people using VoltDB in production.
Oh, excellent. And my phone's actually going as we're recording here with people asking questions or sending me questions that they'd like me to ask you. Somebody's asking, how easy is it to migrate from Oracle to VoltDB? Is that possible? And have people done it in the past?
It's certainly, it depends a lot on your application now. So if you've built your system where you've really abstracted the database level and you've got a nice clean interface between what your application is doing and how it's accessing the database, then it may be a smoother transition. But it's not certainly not a drop-in replacement for systems like Oracle. Again, in this sense, it's a little bit more like some of the NoSQL systems where there's a little bit more application restructuring you're going to have to do to get running on VoltDB. That said, VoltDB is SQL. It's relational, so a lot of your schema is a simple transition. A lot of the manipulation you do to data is very easy to understand if you come from an Oracle world, and the consistency level is stronger than you get with almost every relational database. So when you are running your stored procedure, you actually own the data 100%. So that from that standpoint, a lot of your experience is going to translate.
Okay, excellent. I was curious, is there any kind of link between, I noticed that Michael Stonebreak is still, you mentioned he was involved originally, and he still serves as CTO, I believe,
absolutely,
at VoltDB. He was also involved with Ingress as well, I was reading, and Postgres and some of their stuff as well.
Yeah, Mike is a serial database startup guy. He's been involved in a lot of companies, as you said, Ingress and Postgres, but also in the area right near here, Vertica, Streambase, and a couple others. He's now doing, I believe, SciDB, which might be ZX, or is a completely different system. So he's got his hands in a lot of pots, but he's been a tremendous resource at VoltDB. The man has a lot of experience, and stops by frequently to run over technical discussions and kind of plan where we go with VoltDB. It's been great working with him.
Excellent. So I was a bit curious. I know we've kind of we've talked a little bit about the link possible, or not link. I shouldn't keep saying that, but the kind of as you said, the links between Postgres and all these other things. Is it possible that VoltDB will eventually replace Postgres? I know that might be a controversial question, but I'm curious.
Well, I think that we're kind of the consensus. I feel people use the word polyglot a lot, but we're moving into a realm where people are building more specialized systems to handle these higher throughputs. Postgres is about as general a system as it gets for data storage. It kind of does everything decently, but doesn't necessarily can't compete in specific areas with systems that are designed for those specific areas. And I think VoltDB is definitely built to be a system designed specifically for this high volume transaction processing, which is a really broad category, a lot of use cases, but VoltDB, we see in the future a lot of people using VoltDB with a companion analytics system. Possibly VoltDB isn't even in the entire transactional system. It may be in concert with something else. Could be VoltDB and Postgres deployed together. So VoltDB replacing some of these really general systems, it'll be a while before that's the case. But people building systems out of these components, VoltDB, Hadoop, NoSQL, legacy systems, we're really excited about making that easier to do. We've got a connector in VoltDB now that allows you to move data into Hadoop in a transactional way. That's something that's going to be improved quite a bit in the next release. But also moving data out of VoltDB into other systems, or moving from other systems into VoltDB. We think that playing nice with as many systems as possible is really an important strategy going forward in this market.
That sounds really great. Hey, I know we've covered a lot about the areas about where VoltDB can actually be applied to. Is there any more you want to say about that, or have we covered enough so people can decide whether VoltDB is right for them or not?
Well, I think that in terms of whether VoltDB is right for you, people come to us with applications that we haven't really even thought of. So it's hard to give as general guidelines. But first of all, to figure out if your app might be a good fit for VoltDB, consider that the data should fit in memory on a cluster of machines, which generally hundreds of gigabytes is not crazy these days, but a lot of people have even smaller data, and that's a good fit. And that means data that isn't necessarily the analytics side of data. Possibly you've got another system like a Hadoop or an analytics database where you put your long-term data. This is just kind of the hot data. And you want that transactional system. That's one of the key indicators that you're interested in VoltDB, is that you like the idea of consistency. You like the idea of what VoltDB offers. This is really important if in your application you need to add things up or count things. A lot of things with numbers or amounts. VoltDB just really excels at that, and that workload can be really vary anything. We've seen, like I said, network security. We've seen advertising. We've seen flash gaming. We've seen people who want to do financial data. We've seen people who want to store. We've got micropayments. People want to store micropayments in VoltDB. Just a tremendous number of use cases that kind of fit that description.
Is this the kind of thing that would be good for a service? Is there anybody that's interested or is already doing something where they're providing VoltDB remote servers to be able to handle and offload some of the stuff like cloud services?
At the moment, not that I'm aware of. However, VoltDB is certainly Amazon EC2 friendly. You can fire up Amazon nodes or I suppose Rackspace nodes or any of the other cloud providers and run VoltDB. It's a real cheap way to get started playing with a VoltDB cluster, especially if perhaps you have a laptop with 2 gigabytes or a 32-bit laptop and you want to start playing with VoltDB. It's really easy to start up an instance and play with Volt. And like I said before, we really are striving to make Volt as simple a system to use as possible. It unpacks into a directory. It's very straightforward. There are not a lot of knobs. Conceptually, there's a little bit of partitioning work and thinking about your stored procedures, but the development, it's very friendly to getting running on these systems.
Very good, very good. Anything that we left out? We know we covered a lot about VoltDB. Anything else that we've left out?
Oh, I'm not sure. I could talk about VoltDB all day, certainly, and of course, we have on our website forums, as I said, and IRC channels. If people want to ask questions, we really try to make an effort to engage the community and respond to people who have questions, either developing apps or just questions about VoltDB.
Great. Well, I appreciate you coming on today. You've had a lot of information for us, and I think you've given a pretty good overview of what VoltDB is all about and whether we'd want to use it or not for what applications it would be good for. So I appreciate you taking your time out of your day. Thanks a lot.
All right. Thank you.
So, hey, Dan, what did you think?
Yeah, really interesting. I'm intrigued. It's a very different way of doing things. I'm not as much of a database guru as yourself, Randall, but it seems really interesting that they're doing things very differently with everything in memory, stored procedures. It's a really radical kind of way to go, and I think it could be big in the future.
Well, and it's certainly, what I'm noticing about all these NoSQL solutions or these modern database solutions that are really trying to sort of break the bounds of what we've had with, say, traditional Postgres and Oracle and MySQL sort of solutions is that they really are solving parts of the problem in really innovative ways, and I appreciate that. And of course, by solving it in different ways, we optimize for different things. That's why I wanted to make sure that John explained pretty much exactly what VoltDB is about. I mean, because React and a bunch of the other ones we've got talked to, MongoDB, all these sorts of NoSQL solutions, all these sort of modern database solutions, all have their pluses and their minuses. And so it's good that there's so many solutions to draw from. But I'm afraid the fear I have is that we'll end up fragmenting, that everybody will be doing their thing in a slightly different way and a slightly different technology. And I suppose we've already seen that sort of in the scripting languages world where, Perl solved problems one way, Python solved it a different way, Ruby came along, solved it a different way. And so you kind of have to be, as he said, a polyglot to really get things done in the world.
Yeah, duplication of effort as well is a huge concern, as you say, because resources, limited resources and stuff. I was intrigued that it's actually come out of an academic background as well, with the whole links to the universities and so on. And I'm wondering if in some way that allows them to be more inventive or daring, because they haven't immediately got a bottom line that they've got to sort out, and they need to make profit straight away. It seems interesting that they develop this stuff in a very academic research environment and then later on kind of move it into the commercial arena.
Well, a lot of big, interesting open source projects start as academic projects. I mean, I suppose Linux would be the one counterexample of that, of being, Linus doing it on his own for the stuff he had to do. But like Postgres was originally Ingress, which was originally an academic project as well. So, I suppose it's like it comes from both sides of the equation. I mean, if you're a commercial operation that needs to have a problem solved, and you scratch your own itch and create something that you could then eventually figure out to open source, that's certainly one source. And being students hanging out, solving, theoretical issues is also another source for that. So,
definitely, yeah.
Good. Okay, well, enough of that. That's my segue to leading up the upcoming guests. So here we go. I'm holding up my sheet right now. Looks like next week we have I'm interviewing John Wigley. You know, I keep telling people I should get a pronunciation key for their names, and I keep forgetting to get that. The Ledger project, which is open source accounting software. I know that sounds really boring, but I mean, how many of you have a checkbook, or you're using something like Excel or whatever just to manage your numbers? This is supposed to be a complete solution from end to end, and all the way up to small office, home office business solutions. So that'll be really fun. And then following week, Dan, you're interviewing Chris Madano about pylons. You want to tell us a little about pylons so we can get people interested in that show?
Yeah, it's I'll be back in the hot seat 2nd of February, Wednesday, 2nd of February, 2 weeks today, and I'll be talking to Chris about Pylons, which is a web development framework, uses Python, and it's quite interesting. It's expanding into all kinds of different areas now, so it looks good.
And you're also taking over the show for Dan Walsh, SE Linux. Tell us about that.
Yeah, SE Linux. It's well, hopefully I'll know a lot more about it once I've spoken to him. But yeah, from the bits that I do know about it, it's an enhanced security layer, which you get on a lot of Red Hat-based systems. They seem to use it a lot. If you deploy something like Fedora or CentOS, you tend to get this a lot. It was developed in conjunction with various different government agencies, and it's essentially trying to harden the Linux base against all kinds of different attacks, really. So yeah, security stuff there.
That looks very exciting. And we have the mystery guest of the week after that. I'm sure you'll have that filled in before it gets to that week. We have Jeremy Carbo. Jeremy, if I mispronounce your name, I'm sorry. And if Jeremy is mispronounced as well, that's even worse. But anyway, Jeremy Carbo, Sunlight Labs, which is about getting open source in government, making government accountable through open source data, open source rules, all sorts of things. That should be really exciting and appropriate given all the WikiLeaks stuff that we've had recently. Ludovic Marcotte is going to talk to us about Packet Fence and SOGO, which are capture portal software for Wi-Fi to make sure that you have the right machines being allowed to access after certain login or authentication steps and so on. Michael Yap's going to talk to us about Joget, which is a rich browser web application framework so that you can have very, very fancy things happening all in your browser, hopefully cross-platform. Darren Schreiber's going to talk to us with the 2600 Hertz project, which is going to be all aspects of telephony and open source. And finally, on the schedule so far, we have Gilad Bracha, which is a really smart guy, I'm told. I don't think I've ever actually talked to him, but he's going to talk to us about Newspeak, which is the follow-on to Smalltalk in terms of being able to do really, really cool object-oriented things, but also in a very, very controlled, security-wise, access only to pieces that you're allowed to have access to sort of thing. Really good new research in coming from the teams that brought us things like Smalltalk. So I'm really looking forward to that one as well. Lots of other people on the short list. You go to twit.tv/floss. There's a list link there from the spreadsheet. Spreadsheet link there from that page. There we go. How about, let's use English, Randall. I keep forgetting to do that. If you see somebody on the list that's way down at the list, you can email them and tell them to email me, and they'll move further up the list. If you have somebody that's not on that list, you can also email them and have them email me. Don't just email me and tell me, I'd like this project on. I'm crowdsourcing this show. I really need you guys to go out and kind of nudge these projects into coming to talk to me. So if you want more desktop apps, please tell your desktop app project leaders to write me. I will definitely be putting more on. It's just whatever people write me, I'm going to be putting those people on because, hey, I'm lazy. I don't have a lot of time to do this show, so we're doing what we can. Let me make sure I have everything else covered here. If you're gonna be around, what am I saying? No, I'm going to be around a lot of different places. If you follow me on Twitter, twitter.com/Merlin, MERLYN, you'll find out where I'm at. In fact, a couple weeks from now, I'm going to be in South America on a cruise, which is why Dan, in fact, you're volunteered again to take over for the show for him for a couple of weeks.
Couple of years. We didn't discuss that.
I need to up the compensation package if it's going to be a couple of years. And also, as I talked about last week, I talked about Joko Cruise Crazy, the cruise that I went on with for Insight Cruises that had Jonathan Colton and a bunch of other really great people. I had 800 pictures I put on Flickr just the other day. So if you go to flickr.com/Randal-Schwartz, you'll end up in my Flickr stream and you'll be able to see those pictures. I got some really great ones too. I'm really, really happy with how the results turned out. I shot 6,000 in order to get 800. So that tells you the kind of shoot ratio you have to do to get really good ones. I think that's everything on my list. Dan, where can we find out about you?
Yeah, you can find me at, the main place most people probably listening to this would know would be Linux Outlaws podcast, which is a weekly show where we talk about developments in Linux, obviously, but also other open source stuff, lots of news, occasional interviews, stuff like that. You can find that at linuxoutlaws.com. and I'm actually heading over to the FOSDEM conference in Belgium, which is going to be really cool. And I'm going to meet up with Fab, my co-host, who's currently cajoling me in the IRC channel here in the Twit IRC. And we're going to meet up in FOSDEM and hopefully get some more interviews there. Really big European developer conference, so it should be a lot of fun. And also, if you want to find anything about me, find my Identica, Twitter kind of stuff, go to danlynch.org, and you can find all the information there.
Speaking of which, you don't have to know Dan's personal cell phone number to send in requests and questions while we're interviewing a guest. Although that was convenient. I thought it was pretty funny. We actually have a live chat room at live.twit.tv when we're taping the show, which is typically 9:30 a.m. Pacific time, 12:30 p.m. Eastern time, U.S., and some ungodly later hour in the UK, and who knows what time in New Zealand. But anyway, you can probably figure it out from those times. And you can actually sit there. We actually watch the chat room to see what questions people might have for our guests. So come along and watch us live and chat with us live, and we will get your questions answered for these guests. I think that covers everything. You got any last words, Dan?
No, I don't think so. Always a pleasure. I'll see you all again soon.
Absolutely. And as I always say to the rest of our guests, I'll see you next time on Floss Weekly.